Okay, so quadratic practice and problem solving. We're going to take it up. So let's see what I got here. Up 7, compression of 8, reflection. Yeah, I got to slow down. Compression of 8 is going to look like this. And then there's no left or right motion, so it's just x squared. There's no h. It's going to be up 70, and it's a reflection. Now, that's certainly some way I could write it, but most of you probably wrote it like this, without the brackets around that, and that makes a lot more sense. So I've got my reflection, I've got my compression of 8, and I've got my up 70. So left 18. Left 18 looks like this. Down 55 looks like that. And a stretch of 90 looks like that. And there you go. A minimum, so that's going to open up. And that's going to be my k value. So y equals x squared plus 9. And that's the only answer you can give if it only had those transformations. Yay! So let's look at this one. Looks like I've got a vertex of 6, 7, 8, and 1. So that's my h. That's my k. It looks like it's over 1, up 1. It looks like it's over 2, 1, 2, 3, 4. Hey, we feeling pretty good about this. Over 3, up 9. 3, 4, 5, 6, 7, 8. I feel pretty good about that. That looks like it's congruent to y equals x squared. It's got a step pattern of over x, up x squared. So that's looking like a equals 1. So I think we can go ahead and simply say that we've got x minus 8 squared plus 1. I'm looking out to my studio audience and seeing if they're giving me the thumbs up, and they are. Okie dokie, so vertex here looks like is negative 5, 0. So that's my h, that's my k. So at the very least, I'm looking at y equals ax plus 5 squared plus 0. Now, there's no point in putting that in. I won't have that next time. Now, my a value, over 1, up 1, is not working. I really don't have a lot of patience in trying to figure it out by looking at the graph. What I'm going to do is use algebra, and I'm going to say that this point here is 4, 2, negative 4, 2. So I'm going to use negative 4, 2, and I'm going to put it in for x and y. So y is 2 equals a minus 4 plus 5 squared plus 0. Who cares? 2 equals a 1 squared. A equals 2, life is grand, y equals 2x plus 5 squared. Forget the plus 0 because it's just silly. Looking out to my studio audience, and they are agreeing with me. Determine which of the following are quadratic. Okay, so we're going to look at their first and second differences. Plus 2, plus 2, plus 2, plus 2. They all must be the same for me to be doing this. First differences are 10 minus 5 equals 5. 15 minus 10, which is 5. Already I know that's not quadratic. I don't know what it is. I don't care. It's probably linear, but I know it's not quadratic. Next, plus 3, plus 3, plus 3, plus 3. 8 minus negative 1 is 7. 35 minus 8. That's too hard for my head. It's too late in the day. 27. 80 minus 35. 45. 143 minus 80. What do I know? I know it's not linear. That's what I think this one is, by the way. I think it'll keep going up and it's going to be linear. I know this isn't linear because they're not all the same. So then I do the second finite differences. Isn't this fun? 27 minus 7 is 20. 45 minus 27. It's not 20, so it is not quadratic. I don't know what it is. Don't care. Did I make a mistake? Studio audience, help me out. What did I do wrong?
For the first one, it's negative. I mean, it's 9. No, like, it's 9.
Oh, it's 8 minus minus, which is 9. Thank you. It's not 7. So that's 9. Does everything else work? 27, 47, 63? No. Yeah, that works. So 27 minus 9 is 18. Uh-oh, uh-oh, uh-oh. 45 minus 27 was 18. If this is 18, ladies and gentlemen, we have a quadratic. 63 minus 45, 18. We have liftoff. This is quadratic. Da 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 da. That's from Dora, the Fiesta Trio. All right, next. Plus 20. Plus 20. Nobody cares on this side as long as they're all the same. First finite difference is 9 minus 1 is 8. 25 minus 9 is 16. 49 minus 25. This is where my head hurts. 24. 81 minus 49. 32. That's your first finite differences. Second finite differences. 16 minus 8. 8. 24 minus 16. 8. 32 minus 24, 8. Da 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 da. I'm quadratic. Okay, ladies and gentlemen. Flip. A student found the equation of the following graph but made 2 mistakes. Explain in words what's wrong with their equation. Well, negative 4 means that it should be positive 4. Negative 3 means that it should go down to negative 3. I go over 1, 2, 3, 4. I go 1, 2, 3. I don't have a problem with either of those. Do you? So their H and their K looks great. Uh-oh. There's no squared there. That means it's not a quadratic. That's a problem. Also, let's look at the A value. It's over 1, down 1, over 2, down 4. They have an A value of positive 1. They need a negative. So they're missing a negative to open down. And they're missing the exponent to make it quadratic. Otherwise, it's linear. That was fun. Anthony. Anthony hits a golf ball off an elevated driving range platform. The platform of the golf ball is shown on the graph below, where y represents the height, probably above ground. Look at that, above ground. So this is ground. And x represents distance from where he hits it from. Which means, who is this? Anthony is standing on top of a platform right here. And that platform is 2 meters off the ground. The ball gets hit, goes up to a maximum. I'm going to look to my studio audience. 16, 17, 18. I think I see a maximum of 1810. What does studio audience think? Okay. So, determine the maximum height reached by the ball. 18 meters above the ground. Now, I could really throw you for a loop here. I could say, what's the maximum height of the ball from the platform? Right? In which case, you'd have to take into account that it was launched from 2 meters off the ground. Determine how far from the platform the ball will go when it hits the maximum height. So, I think we're looking at... Hold on. That's not 10. No, that's 18, yeah. Oh, so the height's 10. Sorry, guys. Going too fast, trying to finish before the kids are done here. So the maximum height is 10. Determine how far. That's 18 meters from the platform. Looking to studio audience. Am I on track again? They're saying yes. How far will the ball land? Boo, boing. And probably won't go down below, right? The ball will probably bounce off and go somewhere. But we know that it's going to hit here, which is 35, 36, 37, 38. Studio audience agrees. How tall is the driving range platform? Well, we figured that one out at the beginning. It's 2 meters off the ground. That brings this to a close, and you all should be working on your quadratic functions progress check. I'll post some solutions to that later on, and then you are done the worksheets for this unit. Congratulations, well done.